All right, let us do a practical of what we just practice using a simulation software. So now we're going to do the practical. Okay. Uh, I promise you that I'm going to extract some of these videos that I have. I have a lot of them that I did for my students. So I'm looking for the one that's going to be relevant to this topic. So this one can serve, okay? So now let us look at this area. This portion is what we call the nameplate. Whenever you get a component you want to work with, always go to nameplate and look out for the directive of the usage. All right, the directive simply means where you're going to get the information about the component and get some parameters to work with. So now let's look at this area. This area now said this sensor is designed to work with the range of 300 milliampere. So the ampere, the current strength, the current carrying capacity of the contact is 300 milliampere. Okay, we are talking about the contact. We are interested about the contact because the sensor is composed of so many chips internally. But what we are concerned about is the contact inside. The contact inside. All right. So the contact is what you're going to transmit your signal. Your signal that you're going to use the sensor to transmit is composed of contact. So that contact is what we want to use. A contact could be the semiconductor right inside. So that semiconductor is going to contact and give you that close open, close open. So we're interested about the close opening. The function of close open is what we need. That's why I refer it to the contact. So now the strength, the contact strength internally is what we now see as the rating of 300 milliampere. That is strength of the contact. All right. Okay, so the voltage also here is telling us that it's going to be 5 volts to 40 volts. Between 5 volts to 40 volts, that is when this that is voltage range that you can subject this sensor to. I repeat again, the voltage range here is 5 volts to 40 volts. So this sensor can work safely when the voltage is confined within 5 volts to 40 volts. Okay, it's not clear again for me to show. Maybe this is a proximity sensor. This one is proximity type. All right, then this one is another electric switch. This is another type of sensor. These two, they are not the same. This one is proximity, then this one is inductive. This is an inductive. Okay, okay, but both of them maintain the same voltage and maintain the same contact strength. Okay, that is 300 milliampere. I hope it's clear. So let's continue and see other characteristics of this so that we can quickly use this sensor to activate. You know that the subject I said that I'm going to treat you and walk you through. One of them is going to be interfacing sensor to a relay. So we're going to do that now. We're going to interface a relay using this sensor. Okay. Now, applications of sensor is as follow. One, if you want to drive a load using sensor, having gone through the nameplate and see that the contact strength cannot power the load. So what you need to do is to interface the sensor with a relay so that the workload of the load of the particular appliance you want to drive will now go to relay, not coming to contact sensor. So what sensor will do is to send signal to relay coil, which the current of the relay coil is not that significant to bounce a heavy load to the sensor. So whenever I want to drive a load using sensor, ensure that you check the nameplate. If the strength of the contact coming from sensor may not be sufficient enough to drive the load, you get to interface a sensor, a relay or a contactor to the sensor. Okay. Okay. Apart from that, it's always advisable. Apart from that, those of you who participated on industrial motor control and automated system, you know that I also taught you that you don't power contactor with a timer direct. If you remember that concept, okay, I told you that it's not advisable, not even advisable. It's so impractical for you to power a contactor No matter how little the contactor is, do not power a contactor direct from timer relay, because the inductive and shunting and vibration reactive coming from the coil will flash uh, the timer, because timer is a sensitive component composed of electronic chips. Okay, so now you know what we call integrated circuit, that is IC. IC is a fragile component. So, and the timer is composed using IC components. So um, we don't energize contactor direct from a timer. No, instead send that signal to a relay. From timer, you send the signal to relay. Then relay now send the signal to contactor. It's better that way and it's safer. All right. Okay. So that same concept is what I want you to adopt here. So it's not always advisable to use sensor to drive a contactor as well. All right. Okay. So you must interface it with a relay. So it's better you send the signal from sensor to a relay, then relay now send the signal to contactor. Is better. All right. So develop the habit of trying to interface your electronics devices with more reliable switching component than sending direct from a fragile component. Okay. All right. So what we're going to do, we're going to use this to drive a relay. Remember in our previous exercise, we are able to power a sensor using power pack. That is, the source of DC is coming from power pack. Okay. You can also power from DC direct if you don't have a power pack. If you're not coming from uh, AC volt signal. Okay. So let's see how we can look at it. 5 to 40 volts DC. Okay. All right. So let's see how we can terminate it. Then let me walk you through the color coding. I remember in this platform that I've treated a color code. I also told you guys that color code system have changed from 17th edition wiring regulation. Now, do not understand the black to be neutral or negative any longer. Black this time for the new color code is positive line, not neutral or negative. It's purely positive line or lifeline. The blue is neutral or negative. All right, so this particular three lines coming from sensor. We also have some sensors that uses two lines, two lead instead of three. Okay. Okay. Study of sensor is not something you just do in a one class and understand it. We have a complete suite for sensor and relay that you must study. Okay. You must take your time to study about their configuration. All right, so let's see how we can terminate it. This one is using three cables. So now, basically this one, like I told you, is our negative here. Okay, this blue is our negative. Then brown is our positive line. So let's see how we can use this power pack to activate this and interface a relay. The connection is quite simple, just like what we did here. Here, exactly what we have here is what you're going to see there. But this one is for simulation purpose. Then this